Hi there, let's talk about the great new features and improvements in version 1.7 of Volumator. So first up, we're going to talk about snapping your volume edges and vertices to grid locations. So this is really helpful in cases when you're working with content that has been authored to a specific geometric grid. It could be procedural content or some other method that's resulted in very aligned geometry. So all of this content here has been made to a 500 grid, and then we've got some other geometry over there at different values. So just to highlight how this works, I've got my locational grid set to 500. This was all made to a 500, but just to prove it, I'm going to drop an actor. We'll use a target point and we'll just drop it in here. And because we have the grid set to 500, it's going to snap to 500 locations. And you can see that all of the both inner and outer sections of the walls here are all made to the 500 grid. Now, we can obviously just build this as normal in Volumator and it'll do a great job of building it, but we want to enforce it as a rule that the volume edges have to be at those same grid locations. And so that's where the snap edges to grid feature comes in. So it's going to be really handy for people working with that kind of content. Now, if you are working with content like this, as you can see here, because of the grid requirement, things are going to be blocky and everything's going to be at 90-degree right angles. And so in those cases, it's actually best to use the voxel-based modes because they are made out of blocks anyway, and you can specify the voxel size to be the same as the grid size, and that will ensure that everything works absolutely perfectly. So it's a really good fit for this kind of geometry. Now, how do we specify the grid size? That is literally just going to use the resolution setting here, so it all kind of works hand in hand together. So because we know that this is in 500, as we've just seen, so we're going to set our resolution to 500, so that will make our voxel blocks 500 units large, and also it's going to make sure that they snap exactly to 500 unit increments. So the outputted volume will have its edges at exactly those points. First off, though, we're not going to snap edges to grid, so we'll just see what this creates, and this will be the existing functionality. And here we go. There is our volume. It fits the space well, captures the shape really nicely. But as we're not locking anything to the grid, you can see that the volume is just sticking out a little bit further from the space here. And it's all a little loosey-goosey. It'll probably work just fine, but if you need really close walls, then this is obviously going to be a problem. And we want to make sure that these are really snapped up against the edges here. So we're simply just going to enable snap edges to grid, regenerate, and there we go. If I come down to the top-down view here, you can see that our volume is absolutely perfect. And if we come back to normal view, we're just going to increase the size here. Come down here. Okay. We can see that there's even a little bit of Z fighting here, where Unreal can't decide what's closer to the camera, the geometry or the volume. So it's like infinitely close to the edge here. And that might actually be a problem for you. And in fact, actually, this will probably show up in testing if I do a quick test here. Volumator is detecting that some of the time, some of these edges here are not covering the space properly. And it's because they're infinitely close to the geometry. And sometimes that's going to show up as not covering the space. So another great thing about this update is that now the voxel-based volumes, such as this one, can now make use of the expand volume feature. And what that means is it will inflate the volume outwards in the direction of the walls, giving us a tiny little bit of buffer. The other perimeter modes, so that's these top three ones here, they already use this feature, and it's super handy to kind of create a little bit of buffer, a little bit of a safe zone into the walls. And now the voxel-based modes, the other three here, can also use that feature. So if we set it to the default, which is 20, these edges on the volume will get pushed out slightly. So let me just select the volume, regenerate. You can see now that it's just sticking into the walls a little bit. If we come down to the top-down view here, you get a better view. So this is the geometry, this is the volume, and you can see it's just pressing into the wall a little bit. And that buys us a little bit of space. And now there's no Z fighting. And in fact, if we do our test, we can see that there's no problems here at all, except for where I flew through the wall there. So this is incredibly helpful for anyone working with grid-based geometry. We're going to try another one here. So we'll get rid of the expand volume just to make sure it's perfectly aligned to the grid. We've got our resolution and grid size set to 500. Obviously, we're going to enable the grid and we're going to start the drone. And there we go. Again, perfectly aligned to the space, perfectly on the grid edges. Come down the top here and we can see that it is absolutely perfect. Let's come over to these 200 unit ones. So we're going to set our resolution down to 200 and we'll start off with this one here. Again, everything's perfect. If that Z fighting really bothers us, and we can either regenerate with increased expand, or we can always use the tweak controls here to push it in and out. Let's try this much larger space here. There we go. Absolutely nailed it. Now, you may have noticed that the voxel building is considerably faster now. So it's actually been a huge speed increase. I put a bit of work into sort of optimizing how voxel generation is done. And it can be 10, 20 times faster than it used to be. So you can see that's almost instant now, which is great because it used to get a bit chuggy, especially with lower resolution amounts. I mean, we have here 400 voxels, and so it was sort of piecing all of that stuff together. So it's quite a lot to do, but yeah, it's mega fast now, which is really great. As we get down to the smaller sizes, you start getting a few different challenges. Let's change this down to 100. And the initial issue is that the min point distance here is sort of the resolution of the detection that then starts needing to be lowered to account for finer detail. Let's try this. So you can see it's got it just perfect though. And as we get into the really small grid sizes, this is only 50, which is absolutely tiny. So we're going to change our resolution to 50. We're going to have to lower our min point down to the minimum. And at this size, we're going to also have to reduce our drone size. Otherwise, it won't be able to get close enough to the edges of this space. But this should just about do it. And there we go. So all of the generation modes support grid snapping. So let's take a little look at Vertex-only mode and how that works with it. So we're back in the 500 grid area. We've got this little area here that we're going to build vertices for. So this is where we place the individual vertices on each corner. And so if you want to snap to grid, obviously you have to set the resolution to the appropriate grid size. So we're going to set this to 500. We'll build it first without the grid, and then we'll enable it and regenerate so we can see the effect that it has. So as long as we're within 500 units of the corners here, then we should be good to go. So we don't have to be like mega exact. Of course, it depends how defined your grid is. So let's start vertices only mode. We're going to fly over to the first new point here. And you can see the original point here has a V sprite on it. That's new for this version, just to make it a little clearer where your vertices are. Like this. I find it in this mode a little easier to fly, to do it from above, but you're welcome to fly right into the geometry here. Okay, so there we go. It's pretty good, but it's not perfect. So let's enable snapping to grid, and we're going to regenerate. And you can see now that all of the points are perfectly aligned with the grid spacing. If we come down to the top here, you can see that it's looking great. Just like the other modes, it has expand is on by default. And so you can get rid of this if you want and have it perfectly aligned. But personally, I like to have a little buffer in there. Okay, so grid snapping is really good for vertex-only mode if your space is grid aligned. And lastly, let's look at vertex editing with grid mode. So if you haven't used it, this allows you to modify the individual perimeter points of a volume. So this applies to vertex-only volumes like we have here, but also any of the 3 perimeter modes, which are the sort of standard modes here. So the only things that don't use vertex editing are the voxel modes. So let's have a little look at this. So if we enter vertex editing, we can see the original points that were added. And obviously these weren't aligned to the grid, but the resultant volume was. So you don't need to worry about exactly where these are placed other than that they're within the range of the grid points. So if I move this point here, the actual outputted volume is not going to be any different because it's still going to snap it to the grid. Yeah. So grid snapping is going to be mega helpful for people that are working with aligned geometry. It works with all the modes. You can use editing. You can do vertices only modes. It's really, really helpful and really flexible too. So naturally, the report has been updated to also show us information about whether or not something is snapped to the grid. So this is really helpful. I'm always making improvements to the report here. So every time a new feature is added, it gets added to the report too, so that you can see exactly what's being used where. And now there's additional things like if the report can't be generated for some reason, it will tell you why and the status of the volumes, if there are any in the map. So you can understand what the cause of that was. And as I'm going to do from now on, the test map that comes with Volumator now also has an example of the grid. So we now have a 10 button here for the build examples. And so if we press this, we can see our example of the grid working here. So this includes one of those pieces of geometry that were made to a specific grid, and it will run you through how to use that and how to toggle it on and off so you can try that out. So any new feature I'm trying to add to the examples here so you can better understand how the feature works. So next up, there's been some improvements in how Volumator handles level nesting, level instancing. And this is where you have sort of layers and layers of multiple levels containing geometry and volumes at different points within the layers. It's going to take me a moment to explain this, but just bear with me. So here we have an empty map, and this will eventually contain the volume. And then we have a map with some geometry in it. And then we have a master map, which will contain both. And this has currently nothing in it. So let's go back to the geometry map. And first off, we're going to drop the volume map in here. We're going to specify the location of that as 0. So this is a level instance, which is basically a sort of instance of the volume map, which has nothing in it. We're going to Control E to make this our active map. So now we are working within the volume map within the geometry map. And we're going to use Volumator to detect the geometry in the parent map. And so here's our volume here. It's got a couple of issues, but it's a very strange piece of geometry. So this volume now exists within the volume map instance here, which is inside the geometry map. So we can show this by hiding the volume level instance. And now the volume goes away. And let's save both. So we'll save the volume map, and then we'll also save the geometry map, which contains the volume map. So if I open just the level instance of the volume map, we can see just the volume. And then if we go back and load up the geometry map, we can see both the geometry and the level instance of the volume map. Okay, I hope that makes sense. So then we're going to go over to the master map. And now we're going to place the geometry map. And this will contain the geometry and also the level instance of the volume map, which in turn contains the volume. So everything is working. So this can obviously be moved around like this, and everything will go with it. And if we want to actually adjust the volume, or we could actually build the volume straight in this map if we wanted to, but we'll select the level instance of the volume map, Control E, and now we can select our volume. We can do whatever we want to it. So we can run a quick test and we can see those issues that we saw earlier. We can make changes to the volume if we want. We can do whatever we like. In this case, I'm going to enable validation and just regenerate the volume. And there we go. We've fixed our volume and we can save, and it works perfectly. And so now if this geometry map was to be placed in another map somewhere else at a different location, we could duplicate this, of course, like this. So if you're using level instances for things like modular or procedural levels, Volumator is going to work really well with that sort of setup. And again, the report has been updated to include information on level instancing. So if you do have any volumes that are in a level instance, it will show you an extra column and it will give you that info. So when I open this map here, there's 3 volumes, 2 of which are in a separate level instance. If there was none in a level instance, then this whole column would disappear, so you wouldn't have to see it taking up space. But you can see that they're clickable buttons. So if I wanted to modify this one here, I could just simply select this, and it will make this the current level instance. And you can see it's bolded now. So now I can make adjustments to it and really easily switch which level instance I'm working in based on the volume that I have selected. So as always, there's a ton of great improvements and optimizations under the hood. Things are running faster and more efficient than ever. But if you do have any other feedback or thoughts, just please reach out as usual. And thank you very much.